For example, okay, so central point, projecting center, and point B is projected as a B dash to the P1, and to the another side, like A point, A1, A2 points are projecting as a dash. So that A dash and B dash are projected points, and on the space, so B and A2, A1s are projecting points, and without dash, those are projecting points. P planes are projecting plane, and S points, central points, are projecting center, or just a center. So here you can see different example. So point A and point B are given, but you can see two centers are given also. So S1 and S2. S1 and S2 are given. How to project it? So if you project A point with using S1 projecting center, so you will get A1 dash. So if you want to project with using S2 projecting center, so you can generate A2 dash. Similar for B. Okay, so the projection of the B is using S2, so you can generate B2 dash, and then with S1 B1 dash. So similar projection ways. Okay, so can be, that is a central projection. As we told you, many objects, the lines, surface, even though the objects can be projected by using a points, one by one points can be projected. Projected into the plane, so such a way. Okay, so central point is given, and this AB curve is given. Okay, so curve is given in the space. How we do? So we can make many points on the curve, and then by using rays. Okay, so from S to that point, we can generate a ray until that will intersect the plane P. So then the point A or A1 can be generated here, and another plane, another point. So many points can be find that the intersection points of the projections, like as a projections on the P. And then if you connect them, that will be a projection of the curve onto the plane P. Okay, so similar like this. So C and D is given in the space, and the line is given on the space, and is using S center. We can have a line like this, rays, and then we can have this line. Okay, so we can generate a plane also. Okay, so by using two lines, a projection line and projecting line. Okay, so projecting line, projecting point, we can generate a plane also. So soon later we'll see those things, how to use this. Okay. So the second way of projection is parallel projection. As we told you that parallel projection, the ray, okay, the projecting ray or projecting side is parallel with a projecting center. Okay, so for example, point T is given, and ray S, the line S is given, and so we will generate a parallel line to this ray. So then that ray intersects the plane P. So then we can generate a point T dash. So point T dash is a parallel projection of the point T to the S ray side. Okay, so similar to the previous example, the triangle can be projected with using a single ray, and then all are parallel, you see, and the projection is parallel projection. Okay. So that is a orthogonal project. If the rays are projection are orthogonal to the projection plane, that means the ray angle to this plane P is very important. So here you can see that angle is less than 90 degree. So if you do this as a perpendicular to the plane P, it's like a 90 degree. So that will be a orthogonal projection. Okay, so if the rays or projection are orthogonal to the projection plane, then the projection is called the orthogonal projection. So this is a parallel projection. So here point B is given, and AS line is given, or ray is given. So projection B dash on the P1, the parallel projection. So or many points are given in the space, and to the and S some ray is given also. So all those things are equal to the A dash. Okay. So because all this lies in one ray, in one line, and here two rays are given, S1 ray and A and B points. Okay, so A and B can be generated to the parallel projection S1, like A1 dash and B1 dash. And if you use a ray S2, that will generate B2 dash and A2 dashes. So this is a orthogonal projection. If the rays, okay, so this S, S2, S1 are perpendicular, orthogonal means perpendicular, okay, so perpendicular to the P, to the plane P, so that will be orthogonal projection. We are looking from the front of the object, okay, so front face of the object. So that is a perpendicular projection or orthogonal projection. So T point in the space and T dash in the P, or triangle shape is given like this, but we are looking perpendicularly to the plane P, and then we are projecting is using parallel lines to each other and generate these red dots and generate this triangle. So there was a question, which channel you post the lesson to. So I will post this recording to the drawing material channel. Okay, so from your own group, you can find your materials. So in the space, so in the picture plane, that can be defined as like, or labeled as XP. Okay, so point X, and that is XP because the plane P. And in the sheet, in the paper, you can write like X, just small x, or X dash, or X2 dash. Okay, so it's depending on the on which plane is this. Okay, but normally we use small character of X. Okay, and how the point can be defined, how the point can be given in an orthogonal projection. Okay, so with using three planes and with using three projected points, how point A can be given. So like this way, like let's say I have a okay, so point A is given. Okay, so the big capital character here, you can see the green point is given. So this point, okay, so this point is given with capital A, and that is on the space. Okay, so in real life. So how can we can draw this one in the two-dimensional paper, two-dimensional space? So we have to make like this 2 lines. Okay, so and we project to this side, V side. Okay, so V is profile view, frontal view, front view. Okay, so front view. On the front view plane, we put that point. Okay, projection. So and then we wrote there with small character and with dash. And how about on the horizontal plane? So just we measure the height of the point, and then put same this okay, same this distance. Okay, so distance x is taken from A, and then put point A, just small capital character A without any dash. So that plane calls horizontal plane, so H. And in the third plane, that is W plane, that is profile plane. So we measure, so let's make a straight line. We measure this distance. Okay, so that distance, and then just make a same distance. Okay, so you can make a 45-degree angle, or you can make you can use a compass. So make this same size. Okay, so then make straight line again, and then you can use this level A. Okay, so that distance are equal to this distance. So then we can define a point A2 dash. So the intersection point give you the A2 dash. So that is the space, the plane W plane. So that this W plane, that's the profile plane. So V plane, let's repeat. Okay, so V plane is a front plane, frontal or front. And the beige color one is H plane is horizontal or top plane. Another way is top plane. That's a front plane. And W is profile plane. Okay, so plane XOZ is a frontal or front plane, and XOY is horizontal plane or top plane, and YOZ is profile plane. Okay, so and we have to use the lines also, because thin lines, not thick one. Okay, so thin lines, thin narrow lines. So point A. So by using these 3 point and these lines, A point is given, only single point is given. Okay, so if you see here, A small a small a dash, small A2 dash, those 3 points means 1 point is given in the space. Okay, so don't say 3 points are given. Okay, only 1 point is given. Okay, don't say 3 points are given. No, only 1 point is given in the space. Okay, but we use a 2-dimensional page. So how it looks like in so I use a SolidWorks. So let me share my screen. So here 3 planes are given. The yellow one is top plane, and blue one is front plane. Okay, and the purple one is right plane. Okay, so and point A is given. So this red point is given in the space. So you see in the space, not it lies. It doesn't lie on a plane, in any plane. Okay, so it's in the space. So we will project it. As a orthographic projection. It's a 90-degree projection to the plane front plane. Okay, so that is V plane, and we will generate this point. Okay, so point A dash point, the green one. Okay, and then if we project to the yellow top plane side as an orthographic projection, we will generate point A, okay, small a, without any dash. And to the purple plane side, that is a profile plane or right plane, we'll generate A2 dash, okay, so A2 dash points. So it's kind of this kind of projection. So if you open to the three sides, so we can see three plane, like front plane and top plane and right plane, and point one, only one point is given here. Okay, so 1 point's projection, point A and point A dash and point 2 dash. Okay, so so 3D space is given. Any object can be generated in this space and then can be projected into the three plane, and then by giving or by drawing this three plane in one page can be given the sizes of any object, okay, in reality, without having 3D. So if we do if we are able to project a point, so we can generate a line also. So the line consists from 2 points and in two ends, right? So from the 2 points, if you generate 2 points projection on the planes, you can generate the line projections also. So here in this slide, the line projection is shown. Okay, so line A and B, line AB, line A, B is given in the space. So point A projection is here, okay, A dash in the B plane, and B dash here, and A is from the top plane projection, and B is here. So by orthogonal projection, so you can see here in the frontal plane V plane, horizontal is H plane, and profile is W plane. The line can be done like this way. Okay, so A B dash, A double dash, B double dash, and A B. So all other points can be generated in between the line. For example, point D is given somewhere here. That lies in the AB. So the note is the points which lies on the line in the space. That points will lie on in their projections, in every projection. Okay, so in their projections should lie this point. For example, big D. So D point lies somewhere in between point A and point B. Okay, so that point should lie on the projections in their projections also. So somewhere in the projection. So projection from in the frontal projection, V projection should lie here, and in the D in the horizontal H projection also lie not here. Okay, so it should lie in between A B in their projections also it should lie. Okay, so how it looks like in the computer in 3D. So here our coordinate system, right? Okay, so the upper one is Z, and this one is X, and that one is Y. So I hide this. So you see point A and point B is given, and the line is given. So the blue line is given. Blue line is given in the space. So if you project it to the blue side, so we will get A dash and B dash line. So this one. Okay, so we'll get this one. And if you project it on the top plane, the yellow plane, okay, so that calls H plane, horizontal plane. So we will get A B line, and then that is a right plane. So if you project it to the 90 degree, okay, so the looking of 90 degree to the purple color, so we'll generate the projection of A2 dash and B2 dashes. Okay, so that is a projections of line A and B, okay, into the orthographic projections. So now let's see how it look like in the projections. So you see, so one line in the plane V, one line in a plane H, and one line plane W. So this line, that line here, and another line. So by changing these slopes, so you can change the position in the 3D space. Okay, so any line with any slope can be given with using these 3 lines. Okay, so 3 lines in 3 planes. Okay, so let's see into the. So there is an example of orthogonal projection of the part. Kind of prismatic shape. Prism shape is given, and on the left hand side. Okay, so this shape is given, but how to? Okay, that is given as a 3D kind of view. Okay, so that is we call this one isometric view. So in isometric view is given like this 3D, but to draw this one is not easy. So but Monge method or orthographic or orthogonal projection is this one on the right hand side. Okay, so that is isometric one. Isometric view is similar to the 3D. Sorry. And right hand side one, orthographic or orthogonal, or are same. Okay, so all are same. Orthographic or orthogonal are same thing. Orthographic projection. That's a 2D. Okay, 2D. So right hand side is to the orthographic projection. So if you see to the right hand side, there is a all characters are small character. Right hand side is big characters. Okay, so whenever if you want to create orthogonal projection, so this kind of thing you will get in examination. Okay, so you will be given kind of isometric view or 3D kind of view with size, okay, with dimensions, with every sizes are written there. So but on your page, on your sheet, you have to draw orthographic projection of it. Okay, orthographic projection of that 3D object, and you need to draw a line, this horizontal line and vertical line, And one side, okay, so front side, so it will be given as a with using an arrow. If there are no arrow, you have to decide yourself and draw it. But before to drawing it, so you have to define a point. Okay, so point B, point A, point C, and point another point here, another point there. Okay, so and then you measure the distance between A and B and A and so this point and between this, and then you have to draw it. Okay, so then in descriptive geometry, these given points can be given as a projection, right? So the projection should be small characters. So and everything in the V plane should be with one dash. Okay, so everything in the plane H, so should be without any dash. Okay, so that's why A, B, D, you see small characters and there are no dash. And in plane W, it should be some C2 dashes or D2 dashes, everything with 2 dashes. Okay, so and so you draw this one, right? How it looks like from the top. From the top view, from the top side, you will see this kind of picture. Okay, so this kind of shape, and then you have to draw it. And the points A and B lies in the same line, so that's why A equal to the B here. And if you see from the front side, from this side, so right side, C and D lies in one line, so that's why C dash and D dash are equal to each other. So A is here and B is here, and from the top is this. Okay, so C is here and D is behind here, that is here. So whatever, if you see from the right side, so you have to draw here, and whatever you see on the top here, you will see this and this, so you have to draw here. Whatever you see from this side, say triangle shape, like, or just let's change the color, another color. So let's make another. So everything in red side should appear in the red side. Okay, so in the V side, V plane side, everything yellow should appear here in the H plane. And if you have the W plane, so everything green side should appear here. Okay, so that's a O, and that's a Z, and that's a Y, that's also Y. Okay, so if you see from that side behind, so everything from there, so what color? The magenta. From that side should appear in here. Okay, so somewhere here on the left hand side of the red thing. Okay, so that's a way how it looks like in the 3D to imagine your imagination. So I did a this one. Okay, so this part is given, okay, in the 3D space, kind of a stairs, and red thing. Okay, so red thing is projected, same like in the blue side, can be projected something like this. Okay, so and this side, this blue side, this stair side, appear like this onto the purple plane. That is W plane or right plane. We call right plane or W profile plane actually. profile plane. And the yellow thing, yellow side to top sides should be projected to the top plane or horizontal plane, H plane, like this way. So if you see in 3 view or orthographic view, orthogonal view, so we'll have this kind of shapes. Okay, so the shape will be here, the red one, and the bottom one. Okay, so this one is in the top, so that calls the front view. So you see the front view, and also we call F, right? Because of front, that is F, and the frontal F. And a top view, you will see this kind of 2 square or 2 rectangles. That is a H plane. So top plane or H plane, horizontal plane. And the third one is the right plane or W plane or profile. Profile. Profile, that is a front. And that is a H one is horizontal. Okay, so this is a isometric. That is isometric view. So in the examination, you'll be given this kind of thing, isometric view shape, and you have to draw yourself with just instrument. Okay, so there are no computer, no software. Okay, on the page, on the 2-dimensional page, this A3 sheet. So you have to draw the front view and horizontal view and the profile view, and using sizes. Okay, so you have to measure is using a ruler, and you have to draw with pencil. And the note is the edge. Okay, so edge should be projected. Okay, so correctly projected. So this point should be projected, lies in one line. Do not draw somewhere here. Okay, so it should be in one line with other projections. So that means a projection. Okay, so this point and that point lies should lie with same level, same line. Okay, all should be same. And the distance of this is equal to distance of that. Okay, so distance of this is equal to distance of this. So everything should match with each other. Okay, so that's a projection rule. If you do wrongly, so that you'll be, it will be decided as you did wrong. Okay, so let's continue. Okay, so if the line is with like this, okay, so the line AB is given in the space, and the line is perpendicular to plane H. Okay, so to the top plane, it's a perpendicular. Projection on the V plane will be like this. Okay, straight line like this. But if you open, okay, so H plane to the dawn, that will be in the 1 point. Okay, so because A and B is lies in same position. Okay, same point. So A equal to B, A equal to B. So if you see this kind of notation, so that means the line is the perpendicular to the H. Okay. So that will be projected to the V plane. Okay, so it's a profile plane. And if the line is perpendicular to the V plane, so that will be something like this. Okay, so if you see from this side, so you will see only 1 point. C dash and D dash are equal, and from the top side you see you will see a line, CD line, like this. So that's this one in the reality. So that is in the 3D, and that is a orthographic projection. That's a projection. That's a 3D. So that's a 3D or isometric view. So that's a projection, orthographic projection. Orthographic projection. So horizontal straight line and a point are given. Okay, so the line is given AB. Okay, so AB line is given, and point K is given. So capital letters, you see. So here you can see the projection of it. So on the plane H, okay, so that's the parallel to the H. So that's why the line is straight like this. And in vertical, in profile projection also, that is a straight. And the point, you see, given like K dash, K double dash, and K itself. So the rule is, if the point in the 3D space, if in the 3D space in real life, if the point doesn't belong to the line, in their projection, some of their projection will not lie on the projected line. Okay, so if the K point, you see, it doesn't lie in one okay, in reality, in real line with capital character. So, but in their projection it lies, because if you see from the top, you will see it lies in some of the projections, but some of them is not, because the height of the point K is higher than position of AB. Okay, so that means if in any projection it doesn't lie, so that means that point doesn't lie in real 3D space. Okay, understood? Okay, so here another projection. So this line is parallel to the horizontal plane, this one. So these two lines are parallel to the horizontal, and the parallel to the frontal projection, frontal straight line, we call frontal straight line. That is a horizontal straight line if the line is parallel to the horizontal plane. If the line is parallel to the vertical, okay, frontal plane, V plane, so we call frontal straight line. Okay, so it's like this. So we project it to the V plane with slope. But if you see from the top, that is parallel to the V plane, so that's why it makes like this. Okay, parallel line to the XO line. And from the side also, if you see from this side to the W plane side, so you will see again the straight line like this. So because of that is a parallel, the line is parallel to the V plane, so V plane. So that's why it looks like this. Okay, so only one slope. It has only one slope. And again, for the M doesn't belong